So in this question, we're viewing Seurat's famous pointillistic painting. So if the average center-to-center distance between two adjacent dots, okay, so I'm just going to draw this. We've got two adjacent dots, roughly, and this distance here is our 0.540 millimeters. What is the shortest viewing distance that you could stand away from the painting and not resolve any of the dots? Give your answer in meters. Okay, we assume that the room is normally lit, so therefore our pupil is dilated to 4 millimeters in diameter, and that the minimum resolvable angle is set by Rayleigh's criterion. Great, so that means we have this. And that the visible part of the EM spectrum ranges from 700 nanometers to 400 nanometers. Okay, so we've seen this before. So here we know that if this is our viewing distance, L for example, we've seen plenty of times before that theta r is going to be given by our 0.54 millimeters divided by L. We also know that this equals 1.22 lambda divided by D. Okay, so we want to solve for L. So let's rearrange this equation for L. What is lambda going to be? Well, we want to know the viewing distance such that we can't resolve any more dots. So what's the closest distance that we're going to start losing dots? Well, if we start subbing in different wavelengths here, right? So the higher that lambda is, the lower that L is. Therefore, that means that really long wavelengths, you have to stand closer to resolve them. Therefore, we want to know where we're not going to be able to resolve any dots. So we want to know where we start losing our short wavelength dots. So therefore, this is going to have to be our 400 nanometers. And we've seen this in questions previously. So when we work that out, we get roughly 4.43 meters. And that's how we do this question.